In this video, we're going to look at the end of task 7. So if you go to the packet and you go to page 18 and go a little bit over halfway, it starts with like triangles are three-sided polygons. That's where I'm going to start in this video, and I'm going to go up until page 20. So I'm going to do questions 8 and 9 in this video from the packet. So in this part of the packet, we are going to talk about triangles. So triangles are three-sided polygons. I'm sure everyone is familiar with what a triangle is. It's one of the first shapes you learn as a kid. Now, we are going to classify triangles based on sides and angles, and we have a way to show that sides are congruent or angles are congruent. So to show sides are congruent, and congruent is just another word for that the angles have equal measure, we use the same number of tick marks. So if I want to show like, if I draw a triangle ABC, if I want to show that AB and BC are equal, I would put the same number of tick marks on both sides. So I'd put 1 tick mark on both sides, or you could also do like 2 tick marks on both sides to indicate that those 2 sides are equal. Or if I want to make an equilateral triangle, I could show all 3 sides are equal by doing 2 marks. It's just that the tick marks have to match. Sometimes when we want to show that all the sides are different lengths, we put a different number of tick marks on each side. Okay? We don't have to, but sometimes they do that to indicate that all 3 sides are different lengths. To show that angles are congruent, we use arcs to show that. So if I wanted to show like angle A and B are equal, I would put the same number of arcs on it. So when we say congruent, we put an equal sign with like a little tilde on top of it. That means they're congruent, which again means they have equal measures. Okay, so if I do another triangle, if I want to show like this one that A and C are equal, I could do an arc and like then put a tick mark in it. As long as they have the same markings in the angle, then that shows that those 2 angles are congruent. And so just like for another one, if I want to show like all 3 angles, again, I could just do 1 arc, but I could also do like 2 arcs on each one. As long as they match, it shows that those angles are equal. So this would show that angle A is congruent to angle B, which is congruent to angle C. Okay, and I could write it same with sides. If I just go back, this would show that AB is congruent to BC, and this would show that AB is congruent to BC, which is congruent to AC. So now we're going to talk about all the different types of triangles. So we can classify triangles either based on their angles or their sides. So for angles, there's 3 ways: acute, obtuse, or right. So an acute triangle, all the angles are less than 90 degrees. So like we could say this is 80, this is 30, and then they have to add up to 180. So this would be 70, and I know it doesn't really look like it's 70, but those could be 3 possible angles in a triangle, and this would be acute because all 3 angles are less than 90 degrees. For an obtuse triangle, you have 1 angle that is greater than 90. So like this angle would be like 120. Now the other 2 angles have to be acute. If they're not acute, if they're more than 90, then our 2 angles would be above 180, and then we wouldn't possibly be able to make a triangle. So an obtuse triangle means 1 angle is obtuse, which is greater than 90, and the other 2 are acute, less than 90. A scaling, let's just skip to a right triangle because that's the 3rd type of triangle based on angles. So for a right triangle, we have 1 angle that's 90. We usually use that box to indicate that it's 90. The 2 sides that make up the 90-degree angle are called the legs. So this would be called a leg, and this would be a leg. Okay, so they're the 2 sides that touch to create the 90. And then that side that's like across from the 90 degrees is called the hypotenuse. And the hypotenuse is always the longest side of a right triangle. Okay, and the legs could be equal. They may not be. But the hypotenuse is always a different measurement than the legs. Okay, so obtuse, acute, and right are based on angles. And then we can also classify triangles based on sides. And we have three types: scalene, equilateral, or isosceles. So scalene is all the sides have different lengths. So if you drew a scalene, you'd either need to make it obvious that they have different lengths or do like the different markings on each side. And if I just wanted to show it, I would say like AB does not equal BC, which does not equal AC. Okay, so none of those sides are equal. An equilateral triangle is a triangle that has all three sides equal. And if it has all three sides equal, all the angle measures are also equal, and that's called equal angular. Okay. So in this triangle, we would say like AB is equal or congruent to BC, which is congruent to AC, and angle A is congruent to angle B, which is congruent to angle C. And one thing we know about equilateral triangle is that because all the angles are equal and they add up to 180, each angle, if we take 180 and divide it by 3, because they're all equal, we would get 60 degrees. And so each angle in an equilateral triangle is always 60 degrees. And then the last type of triangle is an isosceles. So an isosceles has 2 or more sides that have the same length. So it has to have at least 2 equal. It could have all 3. And then it's technically an equilateral triangle, but any equilateral triangle is also isosceles because it does have at least 2 sides equal. Now, for an isosceles triangle, the angles opposite the sides that are equal also have the same measure, or they're congruent, and they're called the base angles. So AB in this triangle is congruent to BC. And if I look at AB, the angle that's across from it is C. So that angle is called a base angle. And the angle across from BC is A, and that angle is the base angle. And base angles are always congruent in isosceles triangles. So angle A and angle C in this triangle are congruent. And then the angle that is not the base angle, the one that's not across from the equal side, so angle B in this case, is called the vertex angle. Okay, and sometimes they just say non-base angle, but the technical name is vertex. And it's very important that you know that there's like 2 base angles, and those are congruent, and the non-base or the vertex angle is not equal if it's strictly isosceles and not equilateral, where the third side is not equal. Because there will be a few problems. I did another video where they're going to give you a base angle and ask you to find the other angles, or they're going to give you a vertex angle and ask you to find the other angles. And you want to make sure you know how to do those problems. Okay. So question 9 is going to examine kind of the relationships between the different triangles. And we're going to think about like, can an acute triangle be right? Can an acute triangle be scalene or isosceles or equilateral? That's what we're going to look at in question 9. So it says, think about each of the following classes of triangles: acute, right, and obtuse. If you look at the definitions, you'll realize they have no overlap. Okay, so what that means is an acute triangle can never be a right triangle because an acute triangle can never have a 90-degree angle. An acute triangle can never be obtuse because an acute triangle can never have an obtuse angle or an angle greater than 90. An obtuse triangle can't be right because an obtuse triangle has to have an obtuse angle and it can't have a right angle. An obtuse triangle can't be acute because one of the angles has to be obtuse, and an acute triangle has to have all 3 angles less than 90. So the relationship between like acute, right, and obtuse are that it's always never. An acute triangle can never be right, an acute triangle can never be obtuse. But these other ones, it's not the case that there's not any overlap. There is some overlap. So it says below, determine the triangles in each class can also have the listed property. Put a check mark beside those that have both properties and then make a sketch. Example, if an acute triangle can be a scale, put a check there and then make a sketch. Okay, so a scalene means that all the sides are equal, and you can have an acute triangle with all the sides equal. It means all the angles are different measures. So if I have an acute triangle, we could do 60, 70, and 50 would be an example. So probably be 70, 60, and 50, because that adds up to 180. And they're all less than 90. So that's just one specific example. An acute triangle could be isosceles. So like for an isosceles triangle, I could have let's see, I could have my two base angles be 80 and 80, which would give me 160, and then this top angle would be 20. And so that's an example of an isosceles triangle that is acute. And equilateral, well, we know that an equilateral triangle always has 60-degree angles. We talked about that before. So an equilateral triangle is always acute. Okay, so I'm going to kind of put that by. So an equilateral triangle is always acute. An isosceles triangle is sometimes acute. And a scalene triangle is sometimes acute. And for this relationship, like an acute triangle is sometimes scalene, it's sometimes isosceles, it's sometimes equilateral, because it could be any one of these examples. Okay, so a right triangle, if we think about it, okay, can I create a right triangle that has 3 different side lengths? And the answer is yes. I could make a right triangle and I could have, let's see, if I did one of the angles, let's see, 30 and then 60 and then 90, that would be an example of a scalene triangle. These 3 sides would all be different lengths. An isosceles right triangle, is that possible? So can I have an isosceles triangle that is a 90-degree or a right triangle? And the answer is yes. If this is 90 and then isosceles, these 2 angles have to be equal. If you do 180 and subtract 90, you get 90. And then if you want the other 2 angles to be equal, divide by 2, you get 45. And so these 2 angles would be 45, which means that these 2 sides are also equal. So you can have an isosceles triangle that is right. And then equilateral, okay, we said an equilateral triangle, the angles always have to be 60. So this is not possible. This is never, okay? A right triangle is never equilateral. An equilateral triangle is never right because you can't have 90 degrees. So then if we talk about obtuse, okay, can I have an obtuse triangle that has 3 different sides? And the answer is yes, I can have an obtuse triangle that has 3 different sides. I can have 3 different angle measures, which means it has 3 different sides. So if I do 180 minus 120, I would be 60. And let's say like this is 40 and this is 20. And then since all the angle measures are different, then all the side measures are different. And again, I could do the tick marks to show that they're different. Okay, and isosceles, can I have a triangle with 1 obtuse angle and 2 equal angles or 2 equal sides? And the answer is yes. And this isn't drawn perfectly. I could have it be like 120 and then 30 and 30. And so my 2 base angles are 30 and my vertex angle is 120. And so that is possible. But then equilateral again, okay, they have to be 60. So this is not possible again. This is never. Okay, I didn't put the checks. So an obtuse triangle again is sometimes scalene, it's sometimes isosceles, it is never equilateral. Okay, and isosceles is sometimes obtuse, and a scalene is sometimes obtuse. Okay, so most of these are sometimes relationships. The never ones come down to like the equilateral with bright and obtuse, and an equilateral is always acute. Okay, and then just remember acute, right, and obtuse, their relationship is always never, is also never. Okay, so that's the relationships between the different types of triangles. If you have any questions, please let me know.